Alright, today's lesson is about common logarithms, which is just log in general, or the log button that we haven't really had to use yet, but just mainly kind of been working around. Before we get to the solving portion of this section, because there is solving in this section also, as I told you about, let's look at a process called the change of base formula. The change of base formula is mostly used if you want to find the log of something. And of course it's a base other than 10, because of course if it is a base of 10, then what you do is you simply type log of whatever the number is, because we've seen that with a couple of our problems. But what happens if I want the log base 7 of 13? I use the change of base formula, and again the change of base formula pretty much is that I have it backwards. Of course I have it backwards. It would be log of b over log of a. The key point is that the base goes down, so whatever your base is drops down here, and whatever your other value is goes to the top. So if you wanted to log base 7 of 13, you would simply rewrite this as log of 13 over log of 7, and you would type in what you needed to get this done. So log of 13 over log of 7, close your parentheses, log of 7, and that is 1.318. They're usually going to have you round to the nearest thousandth, so just kind of keep that in mind as that's going on. So again, typically round to the nearest thousandth. 1, 2, 3, yep. So that's usually what we're going to be doing. So the fun part of what we're looking at. So far we've seen the following types of problems. 1 over 25 equals 25 to the 3x. You've seen log of 2x plus 1 equals log of 4x. You've seen log base 7 of x plus 2 equals 6. You've seen log plus something, log something equals 6. Each of these has a strategy that we should at least have an idea of in terms of using whenever the variable's in the exponent, but you have two numbers that you can write as the same base. We write this as a 5 to the negative third. We write this as a 5 squared. We work everything out. Everything works like it's supposed to. In this situation here, you have a log of something equals a log of something, and because both of these are the same, you simply do 2x plus 1 equals 4x, solve the problem, and you're done. In this one here, when it's log base 7 of something equals a number, because it's a log all by itself, you pretty much want to rewrite it as the exponent form, where you would put 7 to the 6th equals x plus 2. Sorry, my pencil's going so far, but my screen is kind of acting late to my hands. And then if you saw this one, this was yesterday's work, where you have two logs. So what you do is you write this as log of 3 times x plus 4. You work out that side. That all equals 6, and then you solve as we learned yesterday. So again, that's where we are right now in terms of the majority of what we need to know. The key thing here is today we're going to look at where the variable's in the exponent, but we're unable to find a common base. So what we're going to do is use the power property of logarithms to manipulate the problem into something more manageable. Just be sure to pay attention to the tricks so that afterwards, pretty much I can show you how to make it manageable. You just have to make sure that you practice the steps after that, which I believe are starting to get kind of interesting for some of you. Let's just look at a basic example in terms of what we're doing here. If you had 3 to the x equals 9 to the second, we should know this answer to be 4, because 9 to the second is 81, and 3 to the fourth is also 81. So I wanted something where we actually know the answer, just so I could show you. And so what we end up doing is we take a log power property, or we just take the log of both sides. So we take the log of 3 to the x equals the log of 9 to the second. Pretty much just put a log on both sides and use the power properties after that. And so based off of the property we know, this turns into x log 3 equals 2 log of 9. And now since x is being multiplied by a log of 3, you divide both sides by a log of 3, meaning that x equals 2 log of 9 over log of 3. And so then you have to make sure your calculator programming is up to speed. Hit your n over d, 2 log of 9, over log of 3. Be careful if you combine these things a lot, because what happens is that parentheses there at the side of this 9 ends up throwing things off if you're combining them together. But you did see that x is actually 4, but you have to make sure you've got that process down. Trick steps that we need to be ready for are here. If you have something in front of the log 4, what we can do is we take and we pretty much distribute the log 4. So we put 2x log 4 plus 3 log 4. That's a step you're going to need to know. Again, you might want to write that out for yourself because you will need it. And then if you had something like this, 3x log 5 and x log 2, of course we'll be solving for x, and the only way we can solve for x is if there's only one x. And so what we have to do is factor off an x and be left with 3 log 5 minus log of 2. And so when you do all of that, those are the two main tricks you're going to use today to kind of piece everything together. You know, I always like to make sure you're at least mostly prepared for what you need before we get into the drama of what the day is about. So putting all this together, let's make it through some actual problems and see how this works. So what I'm going to do is, again, you have 5 to the 3p equals 15. Typically what we think about doing is rewriting this as the same base, but of course that's a 5, that's a prime number. There's no way you write 15 as a base of 5, so what we're going to do instead is use logs on both sides. So log of 5 to the 3p equals a log of 15. That then means that 3p log of 5 equals log of 15, which means we then divide both sides by log 5, so 3p equals log 15 over log of 5. And so we take that answer and we pretty much divide it by 3. So I guess if you're rounding to the nearest 10,000th, I would go ahead and do this first. So log of 15, I'd probably hit n over d first. Log of 15 over log of 5 is, 1.683. And then from there, we divide both sides by 3 to get 0.561. Let's just see if that's about right. So 5 to the 3 times 0.561. I cross my fingers on this. Look where I'm at, 15.009. So that's about 15, which means we are about right. So again, on your test you will need to be showing me these steps. I do not want you to just guess and check like some of you did on that last quiz. And if you did guess and check on that last quiz, make sure you know how to show the work, because I did not close that door to you before last quiz, but it is closed to you right now. So make sure you learn these steps, because I need you to know the process, not just be able to plug in some numbers and make it work. Other than that, same thing. 4 to the 4x minus 3 equals 6 to the 2x. Because you cannot write these both as a log or a base of anything else, we are simply going to do log of 4 to the 4x minus 3 equals log of 6 to the 2x, which of course becomes 4x minus 3 going in front. Log of 4 equals, 2x log of 6. You then have to now use that trick that we need, because we've got to separate these x's. So this becomes 4x log of 4 minus 3 log of 4 equals 2x log of 6. Now in these tricks that we have, the best thing we can do is to get our x's on one side. And so I'm going to manipulate this a little bit. Be patient, or pay attention to what's going on. But I like the 4x over here because it's bigger, but I want my 2x to move over here with it. But if I move my 2x, I'm going to need to move my 3x over, or my 3 log 4 over here. So I end up with 4x log of 4 minus 2x log of 6 equals 3 log of 4. So again, pay attention to the fact that this stayed on the same side, so it did not change. This was positive, it moved, it became negative. This was negative, it moved, it became positive. From there, we use the trick of breaking off the x, which is x times 4 log 4 minus 2 log 6 equals 3 log 4. And then from there we divide both sides by the stuff on the bottom, so we end up with x equals 3 log 4 over 4 log 4 minus 2 log 6. And again, you just got to be careful to type that in the right way and hope everything works out for the most part, because it does get kind of messy and you do have to trust your instincts, which is why you need to make sure you're practicing your skill. This is also where you need to make sure you're careful when you type it in, because if I type 4 log 4 minus 2 whatever, all this stuff is underneath the parentheses of the log, so I've got to make sure after I type the 4 I close it, minus 2 log of 6. I don't need to close it after that because there's really nothing else going on. But again, 3 log 4 over 4 log 4 minus 2 log 6 is about 2.120. And yes, go ahead and leave that 0 because it does represent the thousandth value. And again, I guess we could check that out. I don't think we will. But like I said, you can check that out on your own. But just to make sure, all you would do is take the 2.120, plug it into that x and see what it is, plug it into that x and see what it is, but I'm pretty sure it's right. Again, just make sure that you learn the process, trust your steps. This is just a way of trying to make sure that you know how to do the actual process itself. Again, when you get to the Math Excel, when you get to the work, that is where everything's going to be. And then of course C just looks a little bit weird, but the thing I want to make sure you understand about C is that this can be rewritten as 3y minus 1 to the 1/2, which means it ends up as 2 to the y equals 3 to the 1/2 y minus 1/2. Because of course we distribute that 1/2 to everything in there. Now that we're here again, you can again have two numbers with two different bases, so we will use logs to both sides. So log of 2 to the y equals log of 3 to the 1/2 y minus 1/2, which just looks messy, but it gets better eventually. You just have to make sure you're careful with your steps. This now becomes y log of 2 equals 1/2 y minus 1/2 log of 3, because remember the exponent moves up to the front from the power property we learned yesterday. You now have to separate this out, so you end up with y log 2 equals 1/2 y log 3 minus 1/2 log 3. Whew. From there, we need our y's on one side because of course if we're going to solve for y we need to factor it off, so we end up with y log 2 minus 1/2 y log 3 equals negative 1/2 log 3. I actually worked this out from the book and didn't know where my negative sign, or I had an answer that was the opposite of what it was supposed to be, and it's because I forgot that negative. So be careful, because even a long time math person did that mistake. Just be careful as you're doing all this stuff because it does get kind of dangerous. Anyway, factor off your y. And divide by the junk that is attached to it. So again, just making sure that is log 2, which is right. That is 1/2. Yep, no y. So we end up with y equals the beautiful answer of 1/2 log 3 over log 2 minus 1/2 log 3. And you now have to take your calculator, which again, this is why I recommend a calculator similar to this. They do have the Casio version of this type of calculator. I think it's like the EX or FS something, but if you ask me about it, I can look on it online if you're not interested in Texas Instruments. But it does help to have a calculator where you can literally type negative 1/2 log 3 over log of 2 close parentheses minus 1/2 log of 3, and actually get the answer you're supposed to get, which is negative 3.819. So with that said, that is a lot of movement, that is a lot of manipulations going on, kind of warming us up as we get ready to wrap up this chapter. Just again, make sure you are practicing the skills. Keep in mind your test is next Friday, and so you will have about 3 days of review after we learn 6.8. The plan this week is that we do this section today, we do 7.7 tomorrow. You get a day to review on Thursday, followed by a quiz on Friday. Remember that quiz is over everything, so make sure you're looking over the quiz that you have. And then next week we start with we end everything with 7.8. We then get 3 days of review and practice for you to kind of get ready for that first test of the fourth quarter, hoping that you start off in a good way. So other than that, go ahead and go over to your Math Excel and let's see what happens. Good luck.